Another type of chemical reactions that do not necessarily proceed in aqueous solution, although they can, are oxidation-reduction reactions. Oxidation-reduction reactions are reactions where electrons are transferred between different species, such as atoms, molecules, or ions. A substance that loses electrons is said to be oxidized, and a substance that gains electrons is said to be reduced. Often, but not always, oxidation-reduction reactions involve elemental oxygen. Let's consider an example of such a reaction, the rusting of iron. In this reaction, solid iron reacts with oxygen gas to form rust, iron-3 oxide. Taking 4 atoms of iron and 3 diatomic oxygen molecules provides just enough atoms to build 3 smallest units of iron-3 oxide, Fe2O3. What happens to electrons in this reaction? Let's look at the reactants first. Solid iron is made up of identical iron atoms, so there is no reason for electrons to go from one iron atom to another. Therefore, each iron atom in solid iron has charge 0. Oxygen gas is made up of diatomic oxygen molecules. Because the 2 oxygen atoms in an oxygen molecule are identical, there is no reason for electrons to go from one oxygen atom to another. Therefore, each oxygen atom in an oxygen molecule has charge 0. Now, let's look at the product. Iron-3 oxide is an ionic compound. It is formed by transferring electrons from the metal, iron, to the nonmetal, oxygen. Each of the 2 iron atoms in the smallest unit of iron-3 oxide donates 3 electrons, getting a charge of 3+, and each of the 3 oxygen atoms accepts 2 electrons, getting a charge of 2-. A total of 6 electrons are donated by the 2 iron atoms, and a total of 6 electrons are accepted by the 3 oxygen atoms. So overall, our compound is electrically neutral. Thus, in this reaction, iron atoms lose electrons, and their charge state changes from 0 to 3+. And oxygen atoms gain electrons, and their charge state changes from 0 to 2-. In other words, iron is oxidized, and oxygen is reduced, and this reaction is an oxidation-reduction reaction. A subclass of oxidation-reduction reactions where molecular oxygen, O2, reacts with another compound with the release of heat are called combustion reactions. Burning fuels such as natural gas or gasoline are examples of combustion reactions. In gas stoves and Bunsen burners, the fuel burned is natural gas, or methane, CH4. The methane molecules combine with oxygen molecules to form carbon dioxide and water vapor. In internal combustion engines, the major component of gasoline, octane, C8H18, reacts with oxygen, also forming carbon dioxide and water vapor. Hydrocarbons, compounds that consist of carbon and hydrogen atoms like methane or octane, are the most common fuels, and when they burn up completely, they always produce carbon dioxide and water. Although many oxidation-reduction reactions involve some substance reacting with elemental oxygen, O2, not all oxidation-reduction reactions do. For example, any reaction between a metal and a nonmetal that leads to the formation of an ionic compound is an oxidation-reduction reaction. For instance, in one of the previous videos, we have watched the reaction between solid sodium and chlorine gas that results in the formation of sodium chloride. It is an oxidation-reduction reaction because the charges of sodium atoms in sodium metal and of chlorine atoms in chlorine molecules are both zero. But in sodium chloride, the sodium atom transfers its only valence electron to the chlorine atom, so that the charge of sodium becomes plus and the charge of chlorine becomes minus. Therefore, sodium is oxidized and chlorine is reduced.